All right, ladies and gentlemen, so it's back to atomic radius, which we had done before, but we had done down the group. Okay, so as you recall, the atomic radius is basically the half of the distance between two nuclei of atoms that are bonded together, or from the nucleus to the outside of the valence shell for a single atom. Now, before we had lithium, so we were sticking with period 2. So we're going to go all the way across the period to go to neon, right? Because we're doing the trend across a period. So we're going to zoom in on neon. Neon has 10 electrons and it's in period 2. So we are going to be having a look at neon. Now, we just discovered that neon has a positive 10 in the nucleus because of the 10 protons. And so that means we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. The way that the atomic radius works is it's based on the attractive force between the positive nucleus and the negative electron. Okay? So, that being the case, you have a negative electron right here, and that means that there is a force of attraction between these two things. Okay? They are attracting one another. Now, because you have only a +3, you have a relatively small attractive force. Now, when we go across to neon, we have a +10. So we have a bigger attractive force. So a bigger attractive force. But you have the same number of energy levels. So there were 1, 2 energy levels for lithium because it was in the second period. And of course, there's exactly the same number of energy levels. 1, 2, 2 energy levels, just like lithium. So what happens is you get a bigger attractive force, so it pulls the valence electrons in closer to the nucleus. So as you go across a period, the atomic radius actually decreases and the atoms get smaller, right? So across a period, the atomic radius decreases. Now I'm going to use green because I was putting the attractive forces in green, so I'm going to use green for this explanation. And so the explanation is, number one, you have the same number of energy levels, but number two, you have more positive charge. So, number three, the valence electrons are pulled closer to the nucleus, and the atomic radius decreases as you go across. And there you go. There's down the group and across the period trends for atomic radius.